Hello, welcome to my talk about DevSecOps security from scratch. My name is Sven Ruppert and I'm developer advocate for JFrog, and we want to talk today a little bit about security and DevSecOps and how all this could be the view for you as a developer. So what we are doing today is, first I want to talk a little bit about why we are doing this one. Then I want to have a view on the different layers of an application, from scratch coding the first line of code up to running, for example, in Kubernetes environment. Then I want to show you how to shift left inside the IDE as much as possible. Then we have a short view about security from jar up to a Docker layer, so what this means for you and what possibilities and toolings you have. And then the last words are more or less about a few security or main security things that I mentioned if you're dealing with Kubernetes and what you already have done if you're doing all this stuff before. So the last point will be the power of integration, how to deal with an existing environment if you have to plug in your toolings, and that's it. So let's start. Security from scratch. If you're looking at the typical development these days, for example, if you want to have a Java app developed running on Linux, wrapped in Docker and then distributed over Kubernetes, we have these different layers. And if you're in the field of cloud native, even there is officially recommended that you're not doing all this stuff with DevOps. It's recommended to implement DevSecOps. But what DevSecOps is, I have a dedicated talk about DevSecOps in more detail, but now we just want to have a few key points that are interesting for this dedicated topic here. What I'm completely excluding here at this point is the concept phase, because I don't want to go in detail how to implement security in the architecture or in the concept itself. This is a separate topic. We want to focus completely on the view a developer will have and how this will look like in daily life. One main thing is, if you are thinking about the application and then wrapping in Docker and then running Kubernetes, what's very clear is that if you have a security issue inside your plain Docker image, or more left, if you have it in your jar, so if you're coding your use case and your jar will have an infected dependency, then this security breach will be there from the application up to the Docker container. And then for every new layer, you will have new vectors that could be used as an attack vector or security for security issues. And the main thing is that in the sum, so all in total, you will have a bunch of different possibilities, and it makes sense to reduce as early as possible all known security issues. One thing is, if you're dealing with software development, and I'm not talking about how to implement, for example, an algorithm safe or secure or what this, but the main thing is, if you're focusing on dependencies, and you should focus on dependencies because you don't want to reinvent the wheel, means that you are adding dependencies on each layer because you're grabbing existing stuff, and for this you have to deal with repositories. If you're going to the Java world, you have, if you're dealing with Maven or Gradle or whatever dependency management tool you need or you want to use. I'm in my example using for Maven. Means that for the development itself, at least I have a Maven repository. If you're, for example, creating a Vardin app, Vardin is a server-side Java framework, and it includes the NPM world because it have to generate some graphical interface for the browser. So even there and on this layer, you not only have the Maven repository, you have an NPM repository as well. If you're going to the Linux layer, then you have, for example, if you're using Debian repositories, because you're not coding stuff for yourself or by yourself, because you're just grabbing libraries or security patches and all this stuff. So you have again a different type of repository. The next would be Docker. Everything that is on this Docker level or the Docker layers or the main thing, if you're starting with a from clause in your Docker file, you're using a Docker repository. And then latest here in this example is Kubernetes with Helm charts or whatever you are using to build a composition of all your services and to manage all this in your environment. So for every dedicated layer, you have some kind of repository, one or more different types of repositories. And all these repositories, they are more or less the base or the volume of all stuff that is coming from outside. Everything that's coming from outside means you have to trust the developer that is maintaining this dependency. You have to trust his way of dealing with compliance, license, and how good he's maintaining his transitive dependencies, how fast he is fixing bugs and all this stuff. So it makes sense to have something that will scan all this over all different layers and repository types. And there Artifactory is just a dream, because you can have in one Artifactory all these different kinds of repositories. And the very good thing is that with X-Ray you're possible to connect to all these repositories and you are able to scan them. I will talk a little bit more in detail about the possibilities of scanning and how to deal all this stuff, but right now, I just want to say everything that's coming from the internet should go inside your repository and should be scanned by X-ray so that you are sure that you're not using stuff with security issues, or at least if you have to use something, that you are aware of all this stuff that's going on. And not only during the time you're developing, it should be done during the time this image, for example, this Docker image, is in production. It should be rescanned again and again every time. Every time that there is a new information for this or over this security database. So X-Ray itself has a security database, so we are grabbing security information from a lot of different sources, and we have a big team there that's just merging all this information together as fast as possible so that we can distribute this as an update to all our X-Ray instance. And even if you're on-prem, you can just trigger on a regular basis this main database and grab the update so that you have the same information as fast as possible inside your closed networks as well. So everything is available via Web UI or via REST API. Why, how, and what we are doing with this, I will come a little bit later. So if you have to define, for example, your compliance rules or security rules from the company, and you have to define them inside a tool, you need some kind of matching. The way we at JFrog are matching this is a very straightforward way. For example, we have first the rule. A rule is just a stateless definition what should happen if you're finding something. For example, if you find something with a CVSS score from A to B, then please write a mail or trigger a webhook or break a build or whatever. So this is just a stateless rule, and with this you can in a fine-grained way define all the things you want to have. And then you have as next the policies. The policies are the aggregation or the composition of these rules. And from the wording, the rules are mostly pure technical or security focused names. The policies can be more in the name of your domain, or the name can be more in the domain of your specific environment you want to use these policies. For example, web app policy or something like this. And then if you have this one, then you need the possibility to connect these definitions to resources, and the resources are the repositories, the build information, and whatever you want to have here as well. And then you can connect via the watch the policy with some kinds of repositories. This is the way how you're defining it. I will show you how to do it in WebUI a little bit later, but just here as plain information. So rule is a basic atomic thing. Policies are combining different rules to some logical Unix, and then the watch is combining the resource or the active data with the policies to have the possibility to give you the match. Okay, so the first thing is, you as a developer, you have a new use case, you have something you want to try, and then you want to start with a tiny fresh project. You're starting with a clean Maven project, for example, with a POM XML, and you're adding the first dependency because you want to have Jakarta Commons lang, whatever. And here we are. So you start with the first use case from scratch and you're writing down the first line of code. And immediately at this point of time, it would be good if you have all the needed information or all the available information about security and compliance issues, because if you start coding your use case or your proof of concept, everything is fine, and then you see, oh, I can't use this dependency because the transitive dependency has some compliance issues, then you wasted already a lot of money. So, and this is what I will show you now, how this will look like in the IDE plugin. I will show it with IntelliJ IDE plugin because I'm using IntelliJ, but we have it for VS Code, we have it for Eclipse, NetBeans, and it's open source. So if you want to have it for your dedicated IDE or for some other tooling, you can just go to GitHub, grab the plugin source code, modify it, and that's it. So yeah, so how this will look like for you inside the IDE. Okay, now we have a short view to the X-Ray IDE plugin. I just added in my Pullman dependency, so this is a Vardian version. It's a little bit older one, so that we can guarantee see some compliance issues. So what you will have in the IDE plugin here some kind of window. I'm using IntelliJ, so it could look a little bit different on Eclipse or whatever. Then you will see the dependency we added here already. Here this 4120, 4120, and then you have the whole dependency tree, and you see there is a security issue with Jackson data binding. What you get is ranking, if it is a high, medium, or low security risk. You will see the license information, what type, version, and so on. The good thing is you can see here all detailed information. For example, if there is already a fixed version available, and what tiny summary of the issue itself. One cool thing is if you are somewhere, then you can just go here and say show in project descriptor. Then you're jumping here back to this one. And the good thing is if you decide to exclude, you can just go here and say exclude dependency. What you will get is a dependency exclusion. That's it. The only thing I want to show you is how to install it. So in IntelliJ it's quite easy. You're going to the plugin, you're searching for JFrog plugin, updating it or just installing it. In IntelliJ you have to do a restart. In Eclipse could be different. And then the only thing you have to do is you're going to the settings of this X-Ray plugin, adding your coordinates, and then you can just connect your IntelliJ to the X-Ray installation. That's it. Have fun. Okay, now we saw how all this stuff looks like in the IDE for you as a developer after you added the first dependency. Now we have, for example, our REST service running, and we want to wrap it inside a Docker image because we want to distribute it later in Kubernetes. What we want to do is now we start with a Docker file, we start with the first from statement, and at this point you have to deal with the next level of technology. So with a from, you are inside your Debian or Linux world, you are grabbing some dependencies, some prepared images, and you have to scan here as well what is in the image, how this is reflecting to your application, if you need these binaries, and so on. And how this will look like, for example, in the web UI, if you want to analyze Docker images or Maven dependencies, and how to define rules, policies, and watches, I will show you right now. So if you have your platform, log in and go to the menu point security and compliance. Here we'll have two different menu entries. You have to start with policies because policies are used inside watches. A policy is a stateless definition what should happen if you find something depending on your definitions. I will create now a new policy. You have to define a logical name for this. Say policy -demo. If you have to deal with a lot of policies, just think about a naming schema so that this is scaling over the time. First of all, you have to decide if it is something from the area security or license or compliance issues. I will select security. You can add a description, but have in mind that this description must be in sync with all changes you are doing over the time. So I personally just leave it blank here right now. A policy is a composition of rules, and rules is a fine-grained thing. Here, exactly the same like a few seconds before. You need a logical name. Then you can choose what's you can use some predefined levels, or you can define the CVSS score by yourself. I just say grab everything, and now you know how sensitive this should be, this rule. And the next thing is you have to define what is the action that should be triggered, or the thing that should happen. So generate violation, sorry for this. Generate violation is just a thing, or it's just the entry in the web UI. We'll show you in a few minutes. But you can trigger webhooks to integrate with third-party programs or other infrastructure components. You can notify the platform user itself, or external ones as well via email if you want. You can block downloads, so X-Ray is always connected to an Artifactory. And if you want to make sure that infected or affected components are not even inside your repositories, you can just say here, block download. If something is unscanned, if you want to block yes, no. The same for release bundles. And the most common thing is failing a build, yes or no. This can be used from pipelines and TeamCity and Jenkins, whatever CI you're using. I'm just generating the violation. Now I have this rule inside my policy, and I can just create it now. The next step is creating a watch. Creating a watch means that you are connecting the policies or a policy you created before with the resources you want to have a look at. So I will say new watch. It's the same here, a logical name, watch demo. And now you have to decide what are the resources you want to look at. I'm just selecting a few repositories I have here. For example, I have my Docker. You can filter here, for example. I have my bin tray, my Docker remote, and that's it. So these two repositories are now scanned. That means this watch is connected to this repository. And now I have to say what should happen. I'm just selecting the policies I want to have combined. Here, the policy demo is now associated with this watch, and I can create everything. After this is done, you have this overview here in this menu pane watches, and you can see what are the connected resources, and you can calculate the amount of violations. Here you will have 0 because I just created this watch, and there was no trigger to recalculate everything because there was no change, not inside the repository, no build was triggered, nothing. But you can trigger it manually. For example, just have a look at the last 90 days or whatever you want to define, and then it will start calculate this one. It will take a few seconds, but I've prepared here something a little bit earlier. This one. Oh, let's go back. So if I'm going here to calculate, you will see here you have this 400 and something violations. You can have a detailed list. You can filter this list if you want. You have this one, and then you can just grab one of these items you want to have a look at. You see this small text snip that will give you a short information. You see what's the level, the classification level of this security issue, and what is the resource we found it in. What is the component? Here it's a Debian Buster Docker image, and it's used in my created Docker image that is based on this component, or it's containing this component Debian Buster. If you're clicking here, you will see the impact graph. So it's inside the Debian Buster IP tables binary, inside this Docker layer, inside my image. So some additional information is here. The good thing is all of this is available via REST as well. It means if you want to have this information for your reporting system or whatever you want to do with this, or you want to trigger some external other infrastructure parts, you can do this via REST. You can consume this information, or you can just trigger a webhook. So this is the web UI and the core functionality of X-Ray. We saw now how to deal with the web UI. We are able to define rules and policies, and we can scan over different layers. So we are now able to scan from the jar over the Linux layer to different Docker layers. So we have the whole dependency tree here, and we have the possibility to see on every update, if it is with a dependency or if it is with an update of the security database, we see completely the whole picture of all dependencies and what binary is infected by which kind of security information or license information. The next thing is we want to distribute now this Docker image with Kubernetes and want to make sure that it's running on a huge amount of computers. One thing is checking the internet about Kubernetes. There are some very easy things that are recommended, and they're mostly done wrong, and this is a security issue. For example, using plain text passwords. Well, it's clear, it's nothing new, but people are doing it. And it means we have the challenge that we have to get rid of this. But this is more or less a structural thing for the administrative world. Using unsecured libraries. Well, we are able to scan all libraries already in Linux and all this operating system layers. So we have this information already. Bugs, well, bugs are everywhere, so we have to be aware of this one. Operating system bugs and operating system security issues. Well, if you are going over Linux, then we have that information already. Outdated Docker images. You're writing your from clause inside your own Docker image, and what you can see is what's inside there. So we have this already covered. Untrusted images. Yes, don't grab just an image and use it. Scan it before, and maybe you have to manipulate it. So the next thing is there are some Kubernetes internal security features. Yeah, make sure that you're using them. That is an easy thing. And then you have the typical operating or ops things like using classical firewalls or reverse proxies. Make sure that all nodes are using via secure socket layer communication so that you don't have a man in the middle attack, and so on and so on. So this is a huge stuff, but it's more or less regular stuff that you have to deal with processes to make sure that's not happening, that you have to scan, for example, that nobody's using plain text passwords and so on. But you as a developer, what you can do is, for example, you can use a central Docker registry. Sure. Make sure that inside your Kubernetes cluster, even if someone is requesting something, everything is going over your Artifactory instance. That's the first barrier to the internet. And there you have X-Ray connected, and you can stop downloading or stop using an infected image if there's something you really don't want to have. Then harden your Docker images. We had this already. Continuous rescanning. Every time we are modifying the repository or we have an update in the security database, we are scanning the whole graph again. And this means even if there's a Docker image already in production, we will get the notification there's a security issue, and then you are able to react. Update libs, for sure. But we have one thing that we are not able to cover so far. We have the challenge that if something is already in production and running, and we are rescanning it, we must have the possibility to shut down all active nodes and to force a reload or re-ramp up with a new Docker image. And to make this a little bit more convenient, we have, for example, this tiny open source tool called KubeNup. It's available under JFrog/KubeNup, and this is a Kubernetes dynamic admission webhook. In clear words, it means with this you are able to push your Kubernetes cluster to the direction that he will destroy existing instance and reload with a new Docker image, so that no infected image is running over a long time accidentally because there's a long running process or whatever. So have a look at this one, and then you have some tooling around your Kubernetes universe to make sure that you are fast as possible updating your stuff. The next will be a few words about how to integrate into an existing environment. The power of integration. The power of integration means that if you have an existing infrastructure, and I assume that the most of you will have some kind of existing infrastructure, you need the possibility to hook in with the tooling in this one. And with all JFrog products, it's very, very easy, because every JFrog tool is you have the web UI to use the functionality, but at the same time you have REST API to manage all this stuff. So everything you can do as a human in front of the web UI, you are able to do of the REST API as well. For example, I just took here the X-ray as an example. So what we saw so far, we're able to break a build, notifying and all this stuff. But there are two things that are very, very powerful if you're talking about integration. It is, first of all, the webhook. The webhook will give you the possibility, based on some things or reactions or some information you have, to trigger a webhook, and this will lead you to different or dynamic chosen workflows. The other thing is, if you have, for example, third-party component that you need to use for compliance reporting and whatever, then this tool can just ping the X-ray instance after it's triggered via webhook to modify the instance, to modify workflows, or to grab information out. For example, just give me the information from this report so that I can consume it and put it to my compliance tooling for the next report or whatever you need. So with this, you have the possibility to have dynamic workflows and to interact between machines via REST API. So the integration is very smooth. I'm talking a lot about this stuff, and I'm really happy that I can do all this here with X-ray and Artifactory. But the best thing is if you will try it by yourself. And this is so easy, because you're just going to the trial here to jfrog.com/platform/free-trial, and you can ramp up a trial. I think it will take 10 minutes or 15 minutes, and then you have the whole enterprise environment. It means with Artifactory, with X-ray, with pipelines, with Access, with Edge, everything. So, and then you can just try it by yourself. And it means start a trial. After 10-15 minutes, you have the possibility to create a remote Maven repository, for example, to Maven Central or Bintray. Then you create a watch for this repository, how this is done. I had before, or just check my screencasts or other videos I have on YouTube. Then set Maven to use this created repository, that everything is going over this one. Make a Maven clean verify. So after you added the first dependency for sure. And then check your watch or inside the IDE what kind of information you have already. So all in total, well, maybe an hour, maybe two, and then you're done and you have the first information about your project right now, what's going on here. So thank you very much for listening. If you want to reach me, Twitter is the best way. And yeah, let me know what you learned, what you have as ideas. Feel free to contact me. As I mentioned, Twitter is the best way. And otherwise, have fun today and see you. Today, we want to see how to create your own test engine for JUnit 5. That means in the beginning, we will have a short introduction about the possibilities of the default test engine. The agenda for today. Why we need daily repositories, what's influence and what part of your infrastructure is. The next thing is why you should have an eye on it.